Hi, I'm Aaron Plug, and welcome to the electric vehicle battery switcher. Now, I've gone and animated this particular video, and what you're looking at is a method of changing the battery on an electric vehicle. So, I thought it's kind of a silly idea, why would you do such a thing? But when you start looking at vehicles like service trucks, you start to realize that they might be running 24/7. So, in other words, if they're running all the time, then being able to switch your battery packs might be an advantage. So, as you can see here, we've managed to switch that battery pack in about a minute. Now, I'm guessing it'd probably be 2 minutes, maybe three, maybe five. But either way, it's still a lot faster than what any of the Tesla, you know, EV chargers do right now. And so what you're looking at is you've got a uh, like a loader, and it's on a lower rack, loader and unloader, and it can scooch underneath the cabinets here. And these battery cabinets actually come over and open and pick up the batteries as well as have them ready for the lifter to pick up. And as you can see there, it can go underneath the cabinet with the battery, so it has enough clearance to do that. And now, a few things we have to look at is this floor. You see how it has like a garage door style floor with an opening in it, and so it has to cycle across the underside of the car. And this is for safety purposes. You can't just drive over a pit and go and install batteries that way. You kind of need some sort of guard, and that's what that is. Uh, when it's done, it has a plate on the far side that it kind of hides underneath. And I've been debating about, you know, should the plate be mobile? Could it move across uh, the length of the overall unit? I do have a measurement here. Uh, Length 325 inches or 8 meters or 8 and a quarter meter. Width 130 inches or 3.3 meters, and height is 82 inches or 2 meters. Uh, and this unit would basically, you know, re- go at a gas station or something like a gas station. Probably wouldn't want to have a gas station slash electrical battery switcher. I don't know. Might be some regulations that you'd have to get past there. Um, but let's look at some of the tech that would be required for this. And so I'm just going to pop up a couple things. So I was making a video and it had to do with making a trailer. And so that's some of the assets that I'm using just for this animation. And that's kind of, so you can see, uh, I was just messing around there. But yeah, so back to it. So uh, a scissor lift. So if you look at these scissor lifts, that's basically what I'm envisioning for the device. Something like this that would raise and lower the battery packs. Um, and then you've got the cabinets. Now they're all going on rails. So I'm picturing using this sort of rail setup for the power to be able to charge all the cabinets and to keep the electronics all in line. So I have these located along the walls and possibly and on the floor underneath for the loader unloader. But the cabinets, they probably would need these along the walls. And of course, you got the rolling garage door. You can see it rolls up, and if it had an opening to allow the passing through of the battery. And is a garage door strong enough? Well, apparently Elon can walk on the back of the Cybertruck, so that means that it's probably strong enough, or at least there's the engineering to make it strong enough and make this a reality. Um, and so I was looking at the weight of these trailers. This is a 3-ton trailer, uh, and this is some of the trailers that you'd end up seeing uh, being towed by a pickup truck. Uh, and of course, the energy needed. Is there going to be enough energy in the truck? And at what range can you tow this sort of thing? So I did some calculations, and uh, you're going to be, you're definitely going to be able to do 400 kilometers or 250 miles um, with an 8 pack of batteries. So you can see this is extremely heavy, but you can see that these are like the heavy duty pickup trucks. So these would probably be like 10 packs, 12 packs, something like that. They would just need more packs and they could pull more weight. So, you know, and that's how the pickups kind of work. Uh, so that's something that you'd have to figure out is how many battery packs you would end up needing in order to be able to, you know, do your daily work, right? And then it'd be handy to be able to just keep going. And that's what this particular setup would allow you to do. Would be able to do as long as you go 400 kilometers and then pull into one of these stations and swap out your batteries. Another 400 kilometers. Next station, switch out your batteries. Just keep going, right? And just go right across the country if you need. And so I just wanted to also show one other thing that I had done earlier. So this is one of the earlier uh, things, and I'm gonna have to click through this. But you can see here that the door just opened. This is a car up top here, and it's lowering a battery pack. And then this is like a forklift type system. And I have a more refined version of it. I just never made an animation of it. But I was struggling because of the size of the whole unit, and I was thinking I need to get it down to a reasonable size, right? So you can see this would be good for maybe like heavy trucks, transport trucks or something. Like you could carry a lot of weight. Like this pack here is like I think it's 2 meters. Like it's a meter by 2 meters by I don't know. I figured probably 2 layers of Tesla battery packs. Anyway, um, so could the Tesla, could the battery packs, the EV battery packs, uh, be put into an easily switchable package? Um, so, this raises a huge question when it comes to cost and financing. How would you go and finance and cost this? And I just gotta get this one. So let's see here. So let's say you have a Model 3 52,000 equivalent of four of these blades would be used. So I call them blades. I call them like power blades. Um, and so, a Model 3 uses about three power blades worth. So if you were to calculate that each one of these blades is solid, it's full of expensive metals and everything, and plus the process to manufacture them. But I'm looking at like $5,000 a blade for each one of those. So you're looking at, you know, uh, like $40,000 worth of battery packs there. So that's a significant part of the vehicle. So my suggestion is that you separate the powertrain and vehicle from the battery packs, and then make the battery packs something that just uh, everybody swaps, right? So what I was thinking was that you could do a daily rental fee of $1 per day per power blade. So, you know, uh, in this case, for eight of them, it could be $240 a month for eight blades to be able to use those for the month. If you have a car, $120 a month. So, but then the thing is that because they're worth $5,000 a piece, and Model 3, that would take it down to $20,000. So now all of a sudden the Model 3 is down around like 30 grand. So you could afford to buy that fairly easily, hopefully. And but like a subcompact car or a three-blade system would be between 15 and 20,000. A mid-sized car or SUV, four-blade system, 20,000 to 30,000. Large-sized car SUV, five to six blades, 30,000 to 40,000 for base price. Pickup truck, six to eight blades, 25,000 to 40,000. And then a large truck or a 10 blade uh, truck, which would be, like anyway, uh, 30,000 to 50,000. You get the idea. Is more in the price range that we are accustomed to. We spend a lot of money on fuel, and especially the bigger trucks, they use a lot of fuel. So that's where this whole system would shine. And then another area where it would shine would be um, the cars, the vehicles themselves would last twice as long, probably, um, just because they don't have all the moving parts. They can regenerate their braking, so they're going to be less wear items. They have less moving parts. Like overall, it just will last so much longer. A car would be an easily like an electric vehicle could be an easy 10-year or more um, ownership. So the suggestion is that your local state, province, or territory purchase and maintain the power blades, and you try to keep those power blades within your province, state, or territory, and change them at every border crossing or something like that. Um, and so anytime somebody buys like a car that uses four blades, then that means that the government would then buy four blades or pay for it. You would get it in your car, whatever, and then you would have to start paying the daily rental fee of $1 per day. So in other words, it's an incentive from the government, but at the same time, you're still able to charge at home. You're able to go on long trips and just swap out battery packs as you go. Um, yeah, there's that, and then the power blades, the battery packs. Yeah, they contain precious metals, which means that so instead of having all your money go to Saudi Arabia or Russia or the United States or whatever, like buying all that fuel is expensive in order to um, maintain your economy. But going and buying a bunch of battery packs that are worth X amount of money because they're full of nickel, cobalt, you know, all the different metals. Um, and so they retain their worth. I don't know if it's a bankable worth, but it's not necessarily a loss. Anyway, and then for owners that own this particular unit, the electric vehicle battery changer, swapper, whatever, um, you're looking probably at about $250,000 to purchase it, not more actually. Uh, yeah. Anyway, um, but the power will be a dollar's worth of electricity in order to charge one of those blades, and then you can turn around and sell them for like a swap fee. You can offer a swap fee, so power plus swap fee, and you're looking at like $5 to $10 per blade or something like that, and that puts profit in the owner's hands. They can charge. They end up making like $1 to $8 per swap, so it can add up pretty quick, and you can see it's doing it fairly quickly. So if you can go and change 8 batteries in a minute, then you know it adds up. So yeah, it's kind of the whole concept, really. Um, but it's fundamental as far as how we use energy. This could be sitting there, so you don't need to come and fill it up. Like, you don't have to bring a tanker truck and fill this thing up, and then everybody has power. Everybody brings their own battery packs. Like, this vehicle brought 8 of them to this unit. It took 8, and it also would add to the grid. Like, you would have all these battery packs just sitting there and, absorbing energy from your solar or wind or water or coal or your natural gas or any plentiful energy source, nuclear. You don't need to run gas. You've got all these other methods of getting energy. It's just getting that energy to the vehicle. So it's something to think about, and I'm just glad I got to be the one to think about it. So thank you for watching my video.